Find the particular solution y equals f of t for the differential equation dy dt equals 8y with the initial condition y of 0 equals -2. This is one of those guys where we split things into two parts, integrate both sides. So the way I'll handle this is I will simultaneously multiply dt to both sides and divide y from both sides. That'll look like u. Dividing y puts the 1 over y on the left, dy is still on the left, and that's going to equal 8 dt. Now we're going to integrate both sides. Okay? Integrate both sides with respect to y on the left, t on the right. When I do that, I end up with ln of y on the left plus some arbitrary c, and on the right I have 8t plus some arbitrary c. Both c's aren't really necessary, so why don't I move that one and just simply get rid of it. Problem solved, problem solved. Now, what I'm going to do is I'm going to, I think I'm going to not solve for y yet. I think I'm going to wait. I'm going to deal with this first. So I'm going to call ut and I'm going to call uy. And so I'm going to plug stuff in. ln of -2 is equal to 8 times 0 plus c, thus giving us c equals ln of -2. So let's put u and u together to get ln of y equals 8t plus ln of -2. Now I know what you're thinking, that ln of -2, scary stuff, don't lose sleep over it, trust me on that one. So let's solve for y, and we'll do that by subtracting ln of -2 from both sides, like so. Let's move that up here. We've got ln of y minus ln of 2 equals 8t. Okay, when you subtract ln's, you divide the inside, so ln of y over 2 is going to equal 8t. By the way, -2, -2, not 2, -2, that changes things. All right, when I both sides like this, or e to the both sides, that cancels out and I'm left with y over -2 equals e to the 8t. Multiply both sides by -2, and y is going to end up being -2 e to the 8t. And that's going to be b. Hooray! During a recent outbreak, the number of people infected increases at a rate proportional to the current number of infected individuals. If 400 people are infected when the outbreak is first discovered and 600 people are infected 5 days later, how many people are infected 10 days after the outbreak is first discovered? So we're going to deal with an exponential function, and we're going to do capital I of t for infected. T is going to be in time. Okay, we're going to have our initial value, which is going to be 400, e to the sum k, t for time. What I need to do is find out what that k is. So what I know is that in 5 days we have 600 people infected. So why don't I, quote unquote, plug in 5 for t, so we'll put 5k right there. Okay, 400 is still 400, e is still e, but on the left side that's going to be 600 people. Now let's find out what that k is and do a little bit of math. Let's divide both sides by 400, like that. That's going to give us 1.5. Is going to equal e to the 5k. In order to drop that k down, let's ln both sides. So ln of 1.5, ln of e to the 5k cancels out, drops down to 5k. So I have ln of 1.5 equals 5k. Divide by 5, divide by 5, and k is going to equal ln of 1.5 over 5, which I already looked at ahead of time, is going to be 0.0811. That's what k is. All right, so now that we know that, we can go back to this equation up here and change this equation to 400 e to the 0.0811 t. Now I care about 10 days later. So this is just me throwing stuff into a calculator. 400 e to the 0.0811 times 10 is going to be 900. give or take, which is going to be B. Infections, aren't they the best? Bacteria in a certain culture increase at a rate proportional to the number present. If the number of bacteria doubles in 5 hours, in how many hours will the number of bacteria triple? Well, we're dealing with exponential stuff. So here is a nice exponential equation. We'll do n for number. That's going to equal the initial value times e to the kt. Now, I don't know the initial value. No clue. So I'm going to leave that like that. Okay, but what I do know is that it's going to be 5 years, and it doubles. So whatever n sub 0 is going to be 2 n sub 0. Divide both sides by n sub 0, like that, and 2 is going to equal e to the 5k. Now, in order to solve for k, we're going to ln both sides, and that allows that e to go away and drops the 5k down. So we have ln of 2 equals 5k. Divide by 5, divide by 5, and I looked at this ahead of time. You are going to get a number, but you know what? I'm going to leave it like that. I'm going to leave it like that because they don't want us to change things around, so I'm going to leave it like that. K is ln of 2 over 5. Now that we have that information, we have K, I care about what's going to happen when the bacteria triples. So I'm going to create a very similar equation that I have over here. And I'm going to do 3 n sub 0 equals n sub 0 e to the 5 times ln of 2 over 5. And you know what? I want how many hours, so I don't know t. So let's get rid of that 5. Silly me, wasn't thinking there. Let's get rid of that 5 and make you a t like so. And you're going to be over 5. All right, much better. Okay. So what I'm going to do is I'm going to do the same thing. I'm going to divide both sides by n sub 0, divide both sides by n sub 0. That crosses out. 3 is equal to e to the ln of 2 over 5t. If I ln both sides, that crosses out, and I am left with ln of 3 equals ln of 2 divided by 5t. In order to get t all by itself, let's multiply the reciprocal. So multiply both sides by 5 over ln of 2. Multiply this guy by 5 over ln of 2. And you end up with 5 ln of 3 over ln of 2. Wild stuff. Wacky, wild, terrible stuff.